OXU121HP, full-speed host, high-speed peripheral, and on-the-go controller. Oxford Semiconductor. Welcome to this training module on the OXU121HP, full-speed host, high-speed peripheral, and on-the-go controller. This training module overviews the Oxford Semiconductor's OXU121HP, a single chipset, full-speed host, high-speed peripheral, and on-the-go controller. USB on-the-go is a new supplement to the USB 2.0 specification that augments the capability of existing portable devices and USB peripherals by adding host functionality for connection to USB peripherals. Portable devices such as cell phones, PDAs, and digital cameras that connect to the PC as a USB peripheral will benefit from having additional capability to connect to other USB devices. USB on-the-go defines a way for portable devices through a mini connector to connect to supported USB products in addition to the PC. USB on-the-go defines two roles of devices: on-the-go A device and on-the-go B device. This terminology defines which side supplies power to the link, which is initially the host. The on-the-go A device is a power supplier, and the on-the-go B device is a power consumer. The default link configuration is that A devices act as USB hosts and B devices act as a USB device. The Oxford Semiconductor OXU121HP, formerly the TD1120, is a single-chip USB on-the-go controller that incorporates a full-speed host and a high-speed peripheral controller. The ports can be configured in one of two modes: one on-the-go port and one full-speed host port, or as one peripheral and two hosts. The OXU121HP replaces existing two-chip solutions by combining a discrete host and peripheral controllers into a single chip, thus minimizing system cost, board space, design complexity, and power consumption. The high-speed peripheral and full-speed host controller combination enables users to perform high-speed USB data transfers for peripheral connectivity when connected to a host device, and operate at full speed in host mode operation to maximize system power performance. The OXU121HP enables embedded systems to operate as a USB host and peripheral simultaneously, thereby dramatically expanding the degree of interconnectivity and extending the applicability of USB into many new areas, especially in mobile communications, consumer electronics, and printer applications. It enables high-speed PC synchronization to reduce data file transfer time when operating in USB peripheral mode. In host mode, it enables the system to connect to a wide range of USB devices such as flash drives, keyboards, mice, and still digital images cameras. These mobile applications include smartphones, PDAs, MP3 players, portable media players, digital photo albums, and GPS devices. Here shows the OXU121HP architectural diagram. The single-chip USB on-the-go full-speed host and high-speed peripheral controller has an on-chip charge pump that supports up to 100 mA of current and enables support for a broad range of USB devices. Two DMA channels are used for the high-speed peripheral controller and lowering CPU utilization. The integrated phase-lock loop supports 12 MHz or 30 MHz external crystals or crystal oscillators for system flexibility. 16 kilobytes of on-chip SRAM enables optimum system throughput. The OXU121HP allows for simultaneous host and peripheral operation. The ports can be configured in one of two modes: one on-the-go port and one full-speed host port, and one high-speed peripheral port and two full-speed host ports. The high-speed peripheral and full-speed host controller combination enables users to perform high-speed USB data transfer for peripheral connectivity when connected to a host device and operate at full speed in host mode operation to maximize system performance. There are several steps to place the OXU121HP in power down mode and to return the OXU121HP back to normal operation. Upon returning from any of the power down modes, the OXU121HP does not need to be reinitialized because all of the registers will preserve their states upon entering power down. The host port power down as the host suspend state and the peripheral port power down as the peripheral suspend state. When both ports are in their suspended states, additional portions of the chip can be disabled to further reduce power consumption. This mode is called the power save state. The Universal Serial Bus Specification Revision 2.0 recognizes high current devices, which are 500 milliamps minimum, and low current devices, which are 100 milliamps minimum. The OXU121HP has a V-bus control circuitry and an internal charge pump with 100 milliamps 5 volts V-bus drive strength, which is sufficient for many USB applications. Many other systems have a 5-volt power supply capable of supplying the standard 500 milliamp V-bus drive strength. In such cases, a software-controlled power switch is used with the internal charge pump to control V-bus. The OXU121HP features rich processor interfaces which enable it a glueless interface to popular microcontrollers and DSPs. Apart from the hardware connection, such as bus control, data bus, address bus, and interrupt connection, the software must configure the OXU121HP before the processor enables the interrupt. The listed steps must be carried out. The OXU121HP requires either a 12 MHz or 30 MHz input clock into OSC1 using either an external oscillator or a parallel resonance quartz crystal. If an oscillator is used, leave OSC2 unconnected. The oscillator or crystal must have an accuracy and stability of better than 30 parts per million. A parallel resonant crystal with a load capacitance of 18 picofarad is required for proper operation of the oscillator block. The figure shows a recommended circuit. To assure a quick start of the internal phase lock loop circuitry, a crystal with a high Q or low equivalent series resistance should be used.